Two numbers decide whether an energy upgrade was worth the money, and hardly anyone runs them in the right order. The first is how big the load is that you are attacking. The second is how much of that load the upgrade actually takes away. Multiply those together, hold the result against the check you wrote, and then ask the question nobody in a showroom is eager to raise. Will the equipment still be running when the savings finally catch up to the price? Try it on something ordinary. A refrigerator older than 15 years costs somewhere around $95 a year to run by the Environmental Protection Agency's own estimate through the Energy Star program. That number is the entire load. It is not the savings, it is the whole cost of keeping that machine humming for 12 months, which means the absolute ceiling on what a replacement can save you is $95 a year, and you will never reach the ceiling because the new one still draws power. In practice, you are buying back maybe $30 or $40 a year with a check north of $1,000. The new appliance is genuinely more efficient. The purchase still loses, and it loses on arithmetic that was sitting in plain sight before anyone opened a brochure. That is the key, and it travels. Big load, real share removed, honest price, honest lifespan. Almost every energy upgrade people regret buying did not fail because the product was fake. It failed because the product worked exactly as promised on something that was never costing much to begin with. So let me put the rest of the catalog through the same 4 questions, because the pattern gets stranger as the products get more convincing. Start with what the loads actually are, because nearly every bad purchase in this category begins with a wrong guess about that. The Energy Information Administration's residential survey, the most recent full one covering the year 2020, found that space heating and air conditioning together account for 52% of what a typical American household consumes. Water heating, lighting, and refrigeration take another 25% between the 3 of them. Everything else in the house, every television, every dryer, every game console, every charger, every coffee maker, adds up to the last 23%. Half your energy bill is the air in your house being pushed to a temperature the weather disagrees with. That is where the money is. And an upgrade that does not touch that half or does not touch water heating is fighting over the change in the couch cushions, no matter how clever it is. The desire runs the opposite direction. The upgrades that feel like progress are gadgets, screens, panels, things with logos and apps and a satisfying sense of the future arriving in your utility room. The ones that actually move the 52% tend to be dull, invisible, and slightly humiliating to brag about at a barbecue. Nobody has ever thrown a party to show off their caulk gun. That gap between what feels like an upgrade and what behaves like one is where most of this money goes to die. The easiest place to see it is the small plug-in device that promises to cut your electric bill. You have probably seen these advertised, usually with a name built from the words power, saver, or volt, and a claim about correcting your home's power factor. The physics answer is short. Your residential meter bills you for real power measured in kilowatt hours. Reactive power, the thing a power factor corrector adjusts, does not register on that meter. Utilities do bill some large industrial customers on power factor, which is where the idea comes from, and it is legitimate in that setting. In a house, the correction happens on a quantity you were never charged for. You have bought a capacitor with a light on it. The regulatory record here is not subtle either. The Federal Trade Commission maintains a standing enforcement list covering energy savings claims, and it has spent decades chasing devices that promise fuel or electricity reductions their makers cannot substantiate, including an action against a magnetic gadget sold to drivers as a fuel saver. The pattern repeats because the product is cheap to make and the claim is hard to test at home. If you want a decent rule for anything that plugs into a wall and promises to shrink a bill, ask which of the loads in your house it turns off. If the answer is none of them, no rearrangement of electrons is going to help you. Now move up one rung in credibility to the coatings. Radiant barriers and ceramic paints occupy a strange middle ground because the underlying physics is completely real and the marketing built on top of it frequently is not. A reflective barrier in an attic does reduce radiant heat gain. The Department of Energy puts the effect at roughly 5 to 10% off cooling costs in hot, sunny climates, with the benefit strongest when your air ducts run through that attic, and it warns that dust settling on the surface degrades the reflection over time. That is a genuine, modest, climate-dependent result, and in cooler regions its own advice is to add ordinary insulation instead. The trouble arrives when a coating is sold as a replacement for insulation. In July of 2020, the Federal Trade Commission sued 4 companies selling paint products used to coat buildings and homes, alleging they deceived consumers about the insulating and energy-saving capability of those coatings. One of those cases, against Superior Products International and its chief executive, ran through the federal district court in Kansas, where the complaint described claims of energy savings between 40 and 70% when the product was applied to a building. The court entered a permanent injunction in 2022, barring the deceptive claims and requiring compliance with the federal rule governing how insulation R values may be advertised. A separate coating maker was ordered by a federal court in Florida to stop similar claims, 40 to 70% for a coat of paint against a heating and cooling load that is half your bill. A product that could do that would not need a sales pitch. The verdict here is not that reflective materials are useless. A barrier is competing against several inches of fluffy nothing, and several inches of fluffy nothing wins on price every single time. Buy the barrier if you have a hot attic full of ductwork in a sunny climate and your insulation is already where it should be. Buy it in place of insulation and you have paid a premium for a smaller effect. The solar attic fan deserves more respect than either of those because the logic is close to airtight. Attics get brutally hot. Hot attics push heat down into the house. The sun is free. Put a photovoltaic panel on a fan, exhaust the heat, and the whole thing runs on nothing. It is one of those ideas that sounds finished the moment you hear it. What the measurements found is more awkward. Research out of the Florida Solar Energy Center on powered attic ventilation showed the fan dropping attic temperature by more than 20 degrees Fahrenheit, which sounds like a triumph, while cutting the peak cooling load by about 6% in a house with light ceiling insulation. In the electrically powered version, the fan consumed more energy than the cooling savings gave back. On the solar version, at an installed cost near $850, the payback horizon ran past 20 years, which is longer than the fan. And there is a failure mode that has nothing to do with money. A fan that powerful is pulling air out of the attic, and air has to come from somewhere. If your ceiling plane is not continuously air-sealed, and in most houses it is riddled with gaps around light fixtures, plumbing stacks, and the top plates of walls, a good share of what the fan pulls is the conditioned air you already paid to cool. Building scientists have been blunt about this for years. If the attic ceiling is airtight, you do not need the fan. If it is leaky, the fan is quietly billing you. The safety branch matters more than the arithmetic. In a house with an atmospherically vented gas appliance, meaning a water heater or furnace that relies on a natural draft up a flue, or in a house with a known radon problem, depressurizing the living space becomes a combustion safety and indoor air quality problem. That is work for a contractor with a blower door and a combustion analyzer. Now for a purchase where the product is excellent and the context destroys it. Home battery storage is real technology, well-made, and getting cheaper. The problem is that the financial case for a battery rests almost entirely on something outside the battery, which is what your utility charges at different hours. If your rate has a wide spread between expensive afternoon power and cheap overnight power, a battery can fill up when electricity is cheap and empty out when it is expensive, and that gap is your return. If your utility bills you the same amount per kilowatt hour at 2 in the afternoon and 2 in the morning, there is no gap. There is nothing to arbitrage. You have bought a very sophisticated wine cellar in a town where wine costs the same price every day of the year. Analysts at Pacific Northwest National Laboratory put it plainly, noting that current rate structures, net metering policies, installation costs, and financial incentives are not yet economically favorable for battery-only residential systems without additional revenue opportunities. Check your rate schedule before you check the specifications. It is the cheapest research you will ever do, and it takes about 4 minutes on your utility's website. Hold that one. It comes back, and the verdict changes. The smart thermostat is where this starts to sting a little because these are genuinely good products. The Energy Star program estimates that a certified smart thermostat saves about 8% of heating and cooling costs, or roughly $50 a year. And to earn that label, a manufacturer has to demonstrate savings across real homes using a year of data from each one. So the number is defensible. Trace where that number comes from, though. The Department of Energy puts the ceiling at 1/10 of a heating and cooling bill, earned by letting the house drift 7 to 10 degrees Fahrenheit for 8 hours out of every 24. The savings live in the setback. The thermostat is the thing that remembers to do it. So in a household where someone is home all day, where a family member is cold at 68 degrees, where a dog or an elderly parent or a work-from-home schedule means the temperature never actually retreats, you have installed a beautiful screen running the same program your old dial was running. $50 a year assumes a behavior. If your house will not perform the behavior, buy the thermostat because you like the app and the remote access, and be honest that you bought a convenience. There is a reversal buried in that. The same device that wastes money in a house that never empties out becomes one of the better small buys in a house that empties out hard. Two people who both commute, a family that travels several weeks a year, a cabin that sits unoccupied for long stretches. That is where a device that never forgets beats the $50 average because the setbacks are long and nobody has to be disciplined about them. Same product, same price, opposite verdict, and the deciding variable is not in the box. Which brings me to the one people fight about at dinner. Tankless water heaters are a legitimately better machine in the right house. The Department of Energy's figures put them at 24 to 34% more efficient than a storage tank in a home using 41 gallons of hot water a day or less, dropping to 8 to 14% in a home using around 86 gallons. They also tend to last considerably longer than a tank. That is a real product with a real advantage. The arithmetic collapses in two specific situations, and both are physical. The first is your incoming water temperature. A tankless unit stores nothing, so it has to raise the water from whatever comes out of the ground to whatever you want at the tap, instantly, at whatever flow rate you demand. In a warm region where the supply arrives around 70 degrees Fahrenheit, that is a modest lift. In a northern winter where it arrives in the 40s, the same unit is working at or near its ceiling every time anyone opens a faucet, and the way it protects itself is by cutting flow. That is the shower that goes thin the moment the dishwasher starts. The second is your electrical panel, and this is where budgets detonate. A whole house electric tankless unit is an enormous instantaneous load. A 24 kilowatt model pulls on the order of 100 amps by itself, and larger units pull considerably more, spread across several dedicated high amperage circuits. In a house with a 200 amp service that is already busy, you are buying a water heater plus a panel upgrade, plus possibly a service upgrade from the utility, and that supporting cast can cost more than the appliance did. Set against savings measured in tens of dollars a month, the payback wanders off past the horizon. Gas tankless in a mild climate, replacing a dying tank, with venting and a gas line already close to adequate, is a defensible purchase. Electric tankless in a cold climate, in a house that needs a service upgrade to accept it, is one of the most expensive ways ever devised to get slightly less hot water, which leaves the upgrade people defend hardest because it is expensive, it is visible, and everybody agrees it is a good idea. Whole house window replacement, judged strictly on energy return, is the worst deal in this entire portfolio. The savings are real and they are small. Energy Star estimates that swapping single-pane windows for certified ones saves around $295 a year on national average, with a spread from roughly $70 up to about $500, depending on climate and on what is being replaced, somewhere between 7 and 15% of a household energy bill. Now, the other side of the ledger. Industry cost tracking has put a 10-window vinyl replacement job well north of $20,000, and most houses have more than 10 windows. Divide the check by the savings and the payback runs past 50 years on a product with a service life nothing like that. The exaggeration around this is documented. In August of 2012, the Federal Trade Commission sent warning letters to replacement window marketers over claims that consumers would save more than 30% on their energy or heating and cooling bills, telling the industry that energy savings claims must be backed by scientific evidence. Earlier that same year, 5 companies selling replacement windows settled commission charges over exaggerated efficiency and cost savings claims. One point the agency made is worth memorizing because it is the most common trick in home upgrade advertising. Heating and cooling may be less than half your energy bill, so a 15% reduction in heating and cooling costs does not mean a 15% reduction in what you pay overall. Watch which denominator a salesperson is using. It is usually the flattering one. Now put the restrained version of the same idea beside the overbuilt one because the scope alone flips the verdict. Rather than replace the window, you can add a low emissivity storm window over the one you already have. The Environmental Protection Agency estimates that certified low-emissivity storm windows over single-pane clear glass save on the order of 10 to 20% of annual heating and cooling costs, and a Pacific Northwest National Laboratory analysis of low-emissivity storm windows and panels found savings of 21 to 36% across the colder climate zones, with simple payback periods running from about 4 years to about 13. Storm windows generally cost a quarter to a half of what replacement windows cost, with far cheaper installation. Same problem, same physics, a fraction of the money, and a payback that arrives while you still live in the house. The scope of the intervention, more than the category of the product, is what decides whether the check comes back. At this point, you might reasonably conclude that everything expensive is a trap. So let me change the axis, because a whole column of value never appears on a utility bill, and it rescues several of these. Start with risk. A water heater that fails in a finished basement turns into a flooring bill and an insurance phone call. A window with a rotted sash and a soft frame is a water intrusion problem that keeps getting worse, whether or not anyone cares about the glazing. When you replace something that is failing anyway, the math changes completely, because you are no longer paying $20,000 to buy $295 a year of savings. You are repairing a building envelope and receiving the savings as a bonus. That is the honest case for whole house window replacement, and it is a good one. Judge that job on the frames and let the payback be a footnote. Then there is upkeep, which almost never makes it into the sales conversation. Tankless units in hard water areas need periodic descaling. A heat pump water heater has an air filter that wants attention. Any fan on a roof is a motor and a set of bearings living outdoors. None of these are deal breakers, and all of them quietly erode the return you calculated. A device with a 12-year payback and an annual maintenance ritual has a longer payback than you think. Resale is its own animal, and it does not track efficiency at all. The cost versus value survey that tracks remodeling returns has consistently put vinyl window replacement in the high 60s as a percentage of cost recovered, which is quite good next to a mid-range kitchen remodel and quite terrible if you thought windows were an investment. Buyers pay for windows that look new. Nobody at the closing table is running your payback calculation, and neither is the appraiser. And then there is the value money genuinely does not measure, which is where the battery comes back. Everything said about arbitrage still stands. With a flat rate, the battery earns nothing by moving energy through time. A household on a well pump, though, or in a county where an ice storm takes the lines down for 3 days every couple of winters, or with someone whose medical equipment needs power, is buying something else entirely. The difference between an inconvenience and an emergency. There is no honest way to express that as a payback period. Compared with a portable generator, it is quieter, has no fuel to store, and starts by itself at 2 in the morning without anyone walking out into the weather. Judged as a financial instrument in a flat-rate market, a battery is a poor buy. Judged as insurance for a household with real reason to fear an outage, it can be the best money on this list. Both statements are true, and which applies to you depends on where you live. Comfort belongs in the same column. A house with a room that is unusable in August is a house you paid for and cannot fully use, and the repair for that frequently costs less than the room is worth to you. So which three actually earn their money, and for whom? The first is air sealing combined with attic insulation, and it wins for the least glamorous reason imaginable, which is that it attacks the biggest load in the house for the smallest check. The Environmental Protection Agency estimates that homeowners who air seal and add insulation in attics, floors over crawl spaces, and accessible basements save an average of 15% on heating and cooling costs, which works out to about 11% of total energy costs. Notice that the agency published both numbers rather than only the flattering one. 15% of the 52% that heating and cooling represents is a meaningful bite, and the materials cost a rounding error compared with anything else on this list. The best fit household is an older house with rooms that will not hold a temperature, drafts at the baseboards, and an attic where the tops of the ceiling joists still poke through the insulation. The condition that reverses it is a house already done. If your attic is deep and your envelope is genuinely tight, you have collected this, and the second helping is much smaller. And if there is knob and tube wiring up there or moisture staining the underside of the roof deck, that is a stop and get an assessment situation before anything gets buried under new insulation. The second is a heat pump water heater, the one purchase here where a premium product is straightforwardly worth the premium. It moves heat instead of making it, delivering roughly 3 to 4 units of heat for every unit of electricity it consumes against the 1-for-1 of a resistance element. The Energy Star estimate for a household of 4 replacing a standard electric water heater runs on the order of $550 to $600 a year, with lifetime savings in the thousands. Large share, genuinely large load, which is exactly what the key at the top of this asks for. Best fit is a household currently heating water with electric resistance, ideally in a basement or garage with room to breathe. And there is the condition. These units harvest heat from the air around them, so they want something in the neighborhood of 700 to 1,000 cubic feet of space in a room that stays between about 40 and 90 degrees Fahrenheit, and they cool and dehumidify whatever space they sit in. In a damp basement, that is a small summer bonus. In a tight utility closet or a space already cold in winter, the performance falls off and the beautiful ratio shrinks. If you currently heat water with inexpensive natural gas, the comparison becomes a different and much narrower calculation. The third is duct sealing, and it is the one I would put first for anyone with ductwork outside their living space because the loss it stops is almost comically large. Energy Star puts it at 20 to 30% of everything a typical duct system carries, bleeding out through leaks, holes, and joints that were never properly made, and it credits sealing and insulating those ducts with efficiency gains reaching 20%. You bought a furnace or an air conditioner, you pay to run it every hour it operates, and a fifth to nearly a third of its output is being delivered to an attic or crawl space that has no opinion about comfort. Best fit is anyone whose ducts run through an attic, a vented crawl space, or an unconditioned garage. And here is the condition that reverses it. If your ducts sit entirely inside conditioned space, threaded through interior floor cavities and chases, the air that leaks out is still inside your house. It goes to the wrong room, which is a comfort problem worth solving, but the energy penalty is far smaller and the urgency drops with it. Those 3 share a family resemblance, the 7 regrets do not. Each attacks a load that is already large, removes a real share of it, and costs a fraction of what a window job costs. That is no coincidence. That is the key doing its work. So here is how I would sequence the money, sorted by what you are actually trying to accomplish. If your goal is the lowest bill for the least outlay, the order is air sealing and attic insulation, then duct sealing if your ducts live outside the house, then the water heater whenever the current one gets old enough to worry about. Nothing else discussed here belongs in that conversation. If your goal is comfort, and by comfort I mean the bedroom that is unusable in August or the hallway that behaves like a wind tunnel in February, sealing still leads, because leaks and duct losses cause more discomfort than they cause expense. After that, spend on correctly sized equipment rather than bigger equipment. Oversized systems short cycle, they never run long enough to pull humidity out of the air, and they leave a house that feels cold and clammy instead of comfortable. A load calculation done properly costs less than the extra tonnage and produces a better result. If your goal is resale inside a few years, stop optimizing for energy entirely. Buyers reward what they can see, and the recovery percentages reflect exactly that. Fix what looks tired and let the payback go. If your goal is resilience, buy the battery or the generator and quit pretending it is an investment. It is a purchase made against a specific fear, and it is allowed to be. If your goal is the deepest retrofit you can manage over many years, the sequence is the entire point. Seal and insulate first, then size and replace equipment against the smaller load you just created, and never in the opposite order, because equipment bought for the leaky version of your house is equipment you will overpay to run for its whole life. Nearly every product named here works. The plug-in device is the only one where the physics is against you from the first second. The rest succeed or fail depending on which load they touch, how much of it they remove, what the check was, and who lives in the house. A tankless heater is a good buy in Georgia and a budget disaster in Minnesota. A smart thermostat is a waste in a full house and a bargain in an empty one. A battery is a bad investment and excellent insurance, sometimes on the same street. Windows are a poor energy purchase and an obvious repair when the frames have gone soft. Give yourself the same 4 questions before the next quote lands on your kitchen table. How big is that load? How much of it does this take away? What is the check? How long does the thing live? 4 questions, about a minute of thinking, and they will save you more money than anything in this catalog. If this reordered your list, hit the like button, because somebody is sitting at a kitchen table right now doing this arithmetic backwards. Subscribe if you want more of the math hiding underneath household spending. And one question for the comments: what is the upgrade you would unbuy tomorrow if somebody handed the money back, and what exactly was the pitch that got you? Those answers are worth more than any brochure ever printed.